Hello, everybody. We are ready to do the second part of Unit 4. If you recall, Unit 4 has 7 lessons in it, so we're going to combine several of them together. So in this one, we're combining Lesson 2 and Lesson 3 together. Lesson 2 is the hydrologic cycle, the water cycle that you learned from middle school and elementary school. And then the second part is going to be Lesson 3, which is soil chemical properties. Okay, let's get on with this and see how it goes. The first lesson video is going to be your water. All right, it's Boozman, so it should be some good information on water resources. I need you to get 15 facts for this for me. And let's get on in it and see what we've got. The first objective is to illustrate the hydrological cycle and discuss its significance to plant growth and development. This is a really, really interesting picture. I mean, I wanted to get something interesting. We've all done the water cycle again and again and again and again and again. You learn it in elementary school and again in middle school and again in high school. So we're going to, I just picked a really cool picture. So this is known as the water cycle, a continuous process that describes the movement of water on and above and below the surface of the earth. We have, in this picture, we have glacial ice starting to melt, okay, moving down this way. We have rain coming down the mountains, precipitation, and then, of course, it evaporates it back up into the clouds. Once you have your clouds made, they're going to slide over here and drop their water. We have more evaporation off the surface. Once they drop their water, you have this runoff going down here to refill the oceans. And all of that stuff at the same time, you have trees, which of course this is plant class. This is going to be the important part for us. The plants are bringing water up from the soil and then releasing it out in transpiration. And then that adds to the clouds, which will then come back down to precipitation. When it rains down in here, you have water infiltrating into the ground and then storing as groundwater and then shuffling down into the lower areas of the ocean, and then the whole thing starting again and again and again. Like I said, you've not done this since elementary school. But here are our basic steps just to make sure, covering all of our bases. Evaporation is water from the oceans or rivers or lake heated from the sun and turns into vapor, rising up into the atmosphere. Transpiration is where the plants are releasing water vapor into the air through the process called transpiration, contributing to moisture in the atmosphere, adding more. And of course, you know, the more plants there are, the more humid it will be in an area. That's because of the transpiration. Then you have condensation. As that water vapor rises up, it's going to cool and condense into droplet, making the clouds. And then eventually, when they get full enough, you'll have your precipitation. Those droplets are going to combine and fall back to earth as rain, snow, sleet, or hail. And then once you have that, you have infiltration and runoff once the precipitation hits the ground. All right, some of this precipitation is going to soak into the ground and filtration, replenishing the groundwater supplies, while excess water is going to flow over top the surface, runoff, and wind up in rivers and lakes. So the hydrological cycle, which is the fancy word for water cycle, is crucial for plant growth and development for many reasons. First, it provides our water supply. The plants require water for photosynthesis and the process by which they convert sunlight to energy. And adequate water availability is essential for the healthy growth of the plant. Water is one of the key ingredients for photosynthesis to happen. And then you have nutrient transport. The nutrients dissolve in the water. Water acts as a solvent, helping to transport essential nutrients from the soil up to the plant roots. And then this nutrient uptake is vital for various physiological process. We're actually going to, in the second half of this lesson, to describe plant nutrients and nutrient uptake. Is that this one or the next one? I can't remember if it's this one or the next one, but we'll get there. All right, and then soil moisture. This cycle helps maintain soil moisture levels, which is critical for seed germination and root development. A well-hydrated soil supports robust, meaning healthy, plant health. Robust means healthy and strong. Then climate regulation. As the water cycle influences local and global climates, affecting temperature and weather patterns that can impact plant growth conditions. So all of these things, we know the water cycle is real important. The second objective is to explain the role of specifically precipitation and condensation in the water cycle. Excuse me just a second. Okay, just precipitation and condensation specifically. So condensation, of course, is the process where water vapor in the air cools and changes back to liquid water. Typically occurs when the warm, moist air rises and cools in the atmosphere. Its role in the water cycle is you've got cloud formation. As the water vapor condenses, it makes the tiny droplets that cluster together to make the clouds, which is essential for the water cycle, as clouds are the major component for the atmosphere that holds water together. Now, this is one you may not have thought about when you're thinking about condensation: energy release. During condensation, energy is released in the form of heat, which can influence weather patterns and atmospheric stability. As the water is evaporating, it's warm, but then when it's condensing, it cools down and condenses. Well, it was warm a minute ago, then it's cold. That heat that comes off as it changes is enough to influence climate and weather patterns as that's happening. So that's another part of condensation. Sorry, excuse me. Precipitation, of course, is rain, is the process by which water falls from the atmosphere to the Earth's surface in various forms: rain, snow, sleet, or hail. The role in the water cycle is to return water back to the surface. Precipitation is the mechanism through which water returns to the surface after being part of the atmosphere. This replenishes rivers, lakes, and groundwater supplies. And it's important for soil moisture. Precipitation provides essential moisture to the soil, which is crucial for plant growth and maintaining ecosystems. And this too will influence climate. The amount and type of precipitation can significantly affect total climates, weather patterns, impacting agriculture especially, water supply, and natural habitats. In summary, though, the condensation is responsible for forming clouds and initiating the precipitation. Precipitation is a process that delivers the water back to the Earth's surface, completing the cycle, and together they ensure the continuous movement of water, supporting life and ecosystems. Nice little circle going on there. Okay, the third objective is to talk about transpiration, how transpiration affects the water cycle. Remember, that's the water vapors coming off of the plants themselves. So it is the vital process in the water cycle that involves the movement of water from the soil into plants and then subsequently releasing to the atmosphere as water vapor through small openings in the leaves called stomata. And here's how it affects the water cycle. First, the water vapor contribution releases the release of moisture. Transpiration contributes a significant amount of water vapor into the atmosphere. And again, that's why it's a lot more humid in places where you have a lot more plants. It can account for a substantial portion of the total moisture in the air, especially in forested areas. And humidity regulation, as I just said, the water vapor released through the transpiration increases humidity levels in the surrounding environment, which can influence local weather patterns. The next part about how transpiration affects a water cycle is the cooling effect that it gives in temperature regulation. As the water evaporates from the plant surfaces during transpiration, it tends to cool the leaves down and the surrounding air. This cooling effect can help moderate temperatures in ecosystems, creating more favorable environment for plant growth and other organisms, which is why it's cooler in forested areas than it would be in just paved over areas. Not just for the shade factor, but that cooling effect of the transpiration. And next is the soil moisture maintenance. The water uptake. This transpiration helps to maintain a gradient that allows plants to absorb water from the soil. And this water is lost through transpiration. It creates a negative pressure that draws more water up from the roots, ensuring that the plants remain hydrated. Uh, Important for soil health. By regulating soil moisture levels, the transpiration also supports healthy soil, and that it's essential for the nutrient availability of overall plant health. A lot of the nutrients that plants need have to be dissolved in water for the plants to be able to get them, and so you've got to have the water maintenance afforded by transpiration to help that happen. And the next thing transpiration does is by influencing precipitation. That is, again, water evaporating into the air. It's going to have cloud formation when the water vapor is released through transpiration. It can contribute to the cloud formation, which condenses in the atmosphere, and this can lead to precipitation, completing the water cycle. And therefore, local weather patterns, if you have high rates of transpiration like forests, you can influence local weather patterns, potentially leading to increased rainfall in those regions. And again, so that's why keeping trees in an area is going to keep rain in an area. Whereas removing trees from an area, you're going to wind up drying the place out. And the last part, I think, is for the ecosystem interactions, biodiversity support. By maintaining moisture levels and influencing local climates, this transpiration is going to support diverse ecosystems. The healthy plant communities contribute a balanced water cycle and therefore benefits the organisms that rely on these habitats. So with the plants maintaining transpiration and the water levels through transpiration, it helps maintain the entire ecosystem, the animals and everybody included. So a summary then of the transpiration, it plays a crucial role in the water cycle by contributing water vapor to the atmosphere, by regulating temperature and humidity, by maintaining soil pressure, moisture, and influencing precipitation patterns and supporting ecosystem. So all of this transpiration part is where it's pulling up and then coming out through the leaves and making a tiny little water cycle of its own. Our next objective in the hydrological cycle is to distinguish between runoff and groundwater. All right, and their names pretty much tell you what they are. Oh, let me switch to the next slide. So specifically, runoff is the movement of water, usually from precipitation, that flows over the surface of the land, and then when it occurs, it occurs when the soil is saturated. Remember, we learned saturated soil in one of the last ones. When the precipitation rate exceeds the soil's ability to absorb the water. So the soil has a certain amount that it can absorb, but once you go past that, the rest is going off to runoff. And the characteristics of that, you have surface flow. The runoff travels over the ground surface, eventually making its way to rivers, lakes, and oceans. And the speed of the runoff, it can occur relatively quickly, especially during a heavy rainfall or snow melt, which means that's where you get kind of mudslides going on. Depending if you have like heavy rainfall, you can get some bad runoff. It's going to add to erosion. As it flows, the runoff can cause soil erosion and transport sediments, nutrients, and pollutants back into the water bodies. That's one of the reasons why a delta is one of the most rich types of soils you have, because all the runoff from the rain is bringing it from the mountains into the valleys and down into the deltas before it hits the ocean. So it's bringing soil as it comes through. And its impact on the water bodies, the runoff can contribute to flooding, which can affect water quality of rivers and lakes due to the material that it carries. So you never know what it's going to be bringing with it as it goes through. Now, groundwater, this is the other one. We're supposed to be distinguishing between runoff and groundwater. Groundwater is the water that is infiltrated into the soil and stored underground in aquifers. It's found in the spaces between soil particles and then in rock formations beneath the Earth's surface. You have the characteristics. This is our subsurface water, below the surface water. It's not visible on the surface. I'm not talking lakes and ponds. It exists below ground level and can be accessed through wells or springs. It has very slow movement. Groundwater moves much more slowly than runoff does, often taking days, months, or even years to travel through the aquifers. Now, it is going to go, because of gravity, generally downhill all times, but it goes a lot slower than runoff does. It serves for storage. Groundwater is a significant storage for freshwater and drinking, irrigation, and industrial use. So we do use this in industry and factories and such. It can be stored in large quantities in aquifers. The area of Memphis has had historically one of the best aquifers in the area. Our population is kind of draining it, but historically we've had one of the best. And then recharging the groundwater, it's replenished through the process like infiltration from precipitation and surface water bodies. So this process of infiltrating, where it rains and it soaks down in through the soil to the groundwater, can recharge it after it's been emptied or used, or a drought type period. So summarizing the difference between runoff and groundwater, first their location. Runoff occurs at the surface while groundwater is in the ground, kind of obviously beneath the surface. The movement, runoff is moving much more quickly over land, whereas groundwater moves slowly through the soil and rock. And then the function of both, Runoff can lead to immediate changes in the surface of water bodies, while groundwater serves as a long-term water supply and is crucial for maintaining ecosystems and human needs on the long term. So we have like overland flow here. This is our runoff, all right, and this is the groundwater. Moves a lot more slowly. All right, and let's go on to the next thing. All right, this is a part where we bring in the next lesson. This is lesson 3, which is soil chemical properties. So we finished lesson 2, which was hydrological cycle, and now we're in soil chemical properties. This is your video for this one. Um, I'm going to need you to get 15 facts from this one as well. Try to remember when you try to get the facts, try to get them across the whole video. Don't pile them all up in the front. It's better for you to, because the whole purpose of this is to help you learn the material. All right, now the first objective of lesson 3, soil chemical properties, is to explain these chemical properties and to explain pH and nutrient availability. So we're going to go through all of these things together here. Oh, all right, so under the chemical properties of the soil, we have the soil composition. It's made up of minerals and organic matter, water and air. The mineral content includes silt, sand, and clay. Remember, we learned about these in one of the previous lessons. Sand, silt, or clay, which influence the soil's texture and structure. And then we have organic matter, like the decomposed plant and animal material, which contributes to the nutrient health and soil health. All of those go together to give us our soil's composition. And then we have this thing called cation exchange capacity. Now, we are going to get a little chemistry going on here. Cation exchange capacity. Cation exchange capacity. Now, cations are basically positive ions. Okay. Remember from your chemistry, an ion is just an atom that has a charge. That's all it is. An ion is an atom that has a charge. Cations are positive, and we'll do anions in a little while. They're negative. But all an ion is an atom, any old atom, any atom that has a charge. That's all that we're talking about. So these specifically are positively charged atoms. So this refers to the soil's ability to hold and exchange positively charged ions, which are called cations, like calcium, magnesium, and potassium. Do you see how they all have this little plus on the corners? Okay, positively charged ions. Okay, sodium is also one. Soils with high cation exchange capacity can retain more nutrients, making them more available to plants. So the higher this CEC is, which again is cation exchange capacity, the more nutrients the plants can have. Anion, again, those are the negative ones. While it's less common than cation exchange, some soils can hold negatively charged ions, anions, like nitrates and phosphates. Okay, again, you see these guys are negative. The ability to retain these nutrients is also important for plant growth because the plants need some positive ions and some negative ions. Plant nutrition is the next unit. We'll talk about plant nutrition, where they're trying to get their minerals, okay? And this has a lot to do with it. And then the next part of soil chemical properties, this is what we're working on. Chemical properties of soil. We go down here to the organic matter content, which is the presence of organic matter improves the soil structure and enhances soil retention and increases nutrient availability. Remember, organic matter content is like dead leaves, dead bugs and animals, poop, whatever it is, like worms going through and leaving poop behind, and all of that stuff is part of the organic matter content, which increases nutrients in the soil and helps to support the beneficial microorganisms that help in nutrient cycling. Do you guys remember when you did biology, nitrogen fixing bacteria? Okay. Um, Nitrogen in the air is completely useless. So it has to be turned solid, and that's what these bacteria do. So they turn the nitrogen in the air solid, nitrogen fixing bacteria. So that's some of the microorganisms. There's a couple other things as well. This next one is talking about how soil and pH, soil pH will affect nutrient availability. Do you remember your definition of pH from chemistry and biology? pH is a scale to measure acidity or alkalinity. Acidity, means acid. Alkalinity means base. Okay, so you divide the thing into 7 is neutral, Anything on the bottom half is acidic, and anything on the top half is alkaline or basic. Okay, 0 to 14 is what we've got. 7 is neutral. Values below 7 indicate acid soil, while values above 7 indicate alkaline soil. Different plants are going to need different amounts of these. Okay, and we'll find out when we get into the plant nutrition that if you have acid soil or alkaline soil, you have different minerals that are going to be available to you. Some of them aren't available if you don't have the right pH. So continuing with our soil pH and nutrient availabilities, the impact on nutrients, nutrient solubility, meaning how well it can dissolve in water. The pH level is going to affect the solubility of nutrients in the soil. For example, certain nutrients like iron and manganese and zinc are going to become more available in acidic conditions, while others like calcium, magnesium are more available in neutral or basic alkaline conditions. Okay, so it depends on what, like I said just a minute ago, what nutrient you have uh, is going to do better in more basic or more acid soils. And then you have this thing called nutrient lockout. At extreme pH levels, very acid or very base, some nutrients can become completely locked out, meaning they're not going to be available for the plant uptake at all. For instance, phosphorus can become much less available in higher acidic soils. And then talking about the microbial activity, the microbes in the soil are very, very important to the health of the plants and the ecosystem in general. You wouldn't think microbes had such a big deal, but they do. So the soil pH is going to influence the activity of these soil microorganisms, which is going to play a key role in decomposing the organic matter and cycling the nutrients. Most of the beneficial microbes thrive in a pH from 6 to 7.5, so right near neutral. Okay, 6 to 7.5. So you have to be right there near neutral for most of the microbes to survive well. If you're too far in any one direction or the other, the microbes are going to start to die, and then the plants are going to start to suffer. So the optimal pH range, generally for most crops, are going to prefer a soil between 6 and 7.5, like we just said. If the microbes can be surviving well, then the plants will be surviving well. So this optimal nutrient availability is right there near neutral. Again, this is right here near the middle. However, specific plants may have different pH preferences. There are some that, especially one like, I want to say rhododendrons, the flower of a rhododendron can be blue if you have more basic soil and pink if you have more acid soil. And so people will actually do stuff. They'll put like Epsom salt in it and get blue rhododendrons, or rusted nails and get pink. So you can actually change. It's almost like a litmus paper. So different plants, and then some actually prefer to have more alkaline or more basic soils. All right, to summarize this part on the pH, the chemical properties of soil, including its composition, cation exchange capacity, and organic matter, is going to significantly influence the nutrient availability for plants, how much they can get their nutrients. The pH is a very critical factor that affects the solubility of nutrients, how well they dissolve, and the activity of the soil microorganisms. Maintaining the optimal pH level is going to be essential for ensuring that plants can access the nutrients they need for healthy growth. The next objective is to explain some more about this pH. It's very important, how it affects the nutrient availability for plants. It plays a very crucial role in determining the availability of nutrients to plants. When the pH of the soil is too low, meaning acidic, or too high, alkaline, it can hinder the plant's availability to absorb certain nutrients. Look at this diagram with me here. Okay, do you see the larger part of these bands? Okay, this is nitrogen, very, very important for making proteins. You remember how DNA works? Um, the twisted ladder has a lot of nitrogen in it. And so for every strand of DNA, nitrogen is one of the key ingredients. Well, if you are we've got the range of acidity and the range of alkalinity. If you have strong, even medium acid, you're not going to be able to get as much nitrogen. And look, it's even worse when you get to the acid side. And look at phosphorus. Okay, phosphorus is really not going to work right here. But it's got a weird little thing where it's going to work less here, but then it'll work more here. That's just a particular thing about it, that chemical. Okay, they're all kind of run out this way. So these are the macronutrients in brown, what they need a lot of, and the micronutrients in green. See, boron is doing another one of these weird things where it's really, really easy to get in this acid soil. Then it tapers off and then comes back again. So a lot of this is how these specific chemicals react in water and how well they dissolve. So in acidic soils below 6, certain nutrients like iron and manganese and zinc, there we are down here, iron and manganese and zinc, become more available, but others such as calcium and magnesium here are less available in acid. Conversely, in the alkaline soils above 7, nutrients like phosphorus can become less soluble, making it harder for plants to take them up. And again, phosphorus is one of those weird ones here that when you get above 7, it gets kind of weird. Most of the plants are going to thrive in slightly acidic to neutral, so anywhere between here, okay, slightly acidic and then neutral, where a balanced availability of nutrients occurs. Maintaining the right soil pH is going to be essential for optimum plant growth and health, and as it directly influences the nutrients uptake on overall soil fertility, meaning the plants aren't going to work right if you can't keep their pH balanced. And so if you're looking to improve your soil, testing the pH and adjusting it as needed can make a big difference in the plant's nutrient access. So it's real easy to test what the pH is, and therefore once you can test it, you can fix it. All right, our next objective is going to deal with this cation exchange that we were talking about before. Remember, cations are the positive ions. Any ion is just an atom with a charge. Don't let the word ion make you scared or anything of chemistry. It just means an atom that has a charge. And so cations in specific have positive charges. And so we're going to talk about exchanging these positive charges in the soil. So the cation exchange is a process where the positively charged ions, which are cations, in a solution, meaning mixed in water, are exchanged for other cations that are held in the surface of a solid, typically clay or resin. Here's how it works, and I've got a diagram that helps make this better. So you have a surface attraction where the solid material has a negative charge on the surface, and then it attracts and holds onto the positive charged cation. Okay, go with me here. I've got a picture that makes it all better. So then the exchange mechanism, when a new cation from the solution comes in contact with the solid, it's going to displace one of the cations that are already attached to the surface. This happens because the new cation may have stronger attraction to the surface in higher concentration. And then you're going to have the release of these cations. The cation is going to be displaced and released into the solution, allowing for a dynamic exchange of ions. And this process can continue as long as there are cations in the solution that can interact. The importance in soil and water, this cation exchange is crucial in soil chemistry and water treatment as it affects nutrient availability for plants and the removal of contaminants. And overall, this cation exchange is a vital process in various natural and engineered systems, because we can do this ourselves as well on purpose now that we know how it works, helping to maintain balance and support life. Here's the diagram I was talking about. So you have these negatively charged conditioner particles in these negatively charged conditioner particles are going to hold and store positively charged ions. So this conditioner particle is something like clay or something in the soil. And it holds on to these positives here because this is a big giant negative chunk, and it holds on to the positives. And then the plant roots are going to exchange usually hydrogen. Okay, they get rid of hydrogen and then they take this other positive. They drop off some hydrogen and they take this other positive because hydrogen is a positive. So they get rid of this positive so that they can trade it for this other. Okay, and then the plant roots are going to exchange hydrogen cations for the essential nutrients that they can't make themselves. So since we can make plenty of hydrogen and they're going to have excess of hydrogen, they drop it off into the water, and that gives them a little bit of a negative charge, and then they're going to suck these other positives on because they've given themselves a negative charge. The next one is now to explain how the negatively charged mineral ions are more likely to be leached. Leached means washed away, okay? So we just talked about how the positives, they trade with the hydrogens, and they can add the positives to themselves, but then we've got some negatives, how the negatives might get washed away. So the negatively charged mineral ions are more likely to be leached out due to their interaction with water and soil particles. In many soils, the positively charged particles like clay and organic matter tend to attract and hold on to the positively charged cations. However, the negatively charged ions, the anions, don't have the same attraction, and they are more mobile in the soil. They're going to just float around in the soil. And so that when it rains or when irrigation occurs, that water is going to wash away the negatives that are floating in the water. To wash away these negatively charged ions a lot more easily, leading to leaching, meaning they're washed out and the plant can't get to them anymore. This process is going to result in the loss of essential nutrients from the soil, which can affect the plant growth. So in soil, there's different types of charged particles, some positively like clay and organic matter, and they tend to hold on to the positively charged minerals known as cations. On the other hand, the negatively charged minerals like anions don't stick to these particularly well. So when it rains, we water the plants, the water can wash away these negative charged ions more easily because they are not held tightly to the soil. So this washing away is called leaching, and unfortunately, when this happens, most of the important nutrients in the plant can be lost from the soil, which makes it harder for the plants to grow well. So in short, negatively charged minerals are more likely to be washed away from the soil and lead to nutrient loss and affect overall plant health. So to kind of explain what we have here, we have like this is some organic matter here and some clay particle. Do you see how they're holding on to the positives? Okay, they themselves are negative and they can hold these positive ions. All right, then the plant can send out hydrogen, get rid of hydrogen, and pick up these positives easily enough. But the poor negatives are sitting here floating around in the water, which could be good or could be bad, because then the plants can take these negatives that are floating in the water and use them just fine. That's actually a good way for the plants to get the negative ions. However, if you have rain or overwatering or any like that, this stuff will get washed away and the plants can't use it at all. So let's see what this says here. So the cations, the positive ones, will interact with the negative charges in the organic matter. That's the clay and the dirt and stuff, and on the surfaces of clay particles. The anions usually dissolve in soil water, and therefore they're readily available for the absorption by the root hairs. However, when the rain is heavy, these ions get dissolved and tend to wash away. So do you see how it's positive and negative? And obviously it's positive and negative. We're talking cations and anions, but I'm seeing a good thing and a bad thing is what I mean. All right, so because the negative ones just dissolve in the water like this, where's my mouse? There it is. Because they just dissolve in the water, it's real easy for the plants to take them up. The positive ones, because they stick to the clay and the soil particles, they have to do that cation exchange thing where the plants give up their hydrogen so that they can take some of this other positive. That makes sense? So to get the positives, we need this cation exchange system where the plants give up their hydrogen so that they can take some of these other positives. The negative ones tend to be floating around in the water, which makes it easy for the plants to take them up, unless it's raining real hard or we overwater, and then they all get washed away and the plant can't get them at all. Make sense? I think so. So that's actually the end of our slide today. So we've covered 2 lessons today. I hope you got them. We've got lesson 2 was the hydrologic cycle, and lesson 3 is the chemical components of soil. All right. I think you guys have got this. I'll see you the next time. Bye-bye, y'all.